In this lesson, we're going to learn how to find a magnetic field caused by a line current. There is a wire, and the current is flowing through the wire. Let's say the current is I, then this current causes a magnetic field around it. To the left, magnetic field is getting out of the page. These points represent the heads of the arrows. So we are looking at the arrows getting out of the page. To the right, arrows are going into the page, so we are looking at the tails of the arrows. So those arrows represent a magnetic field. We pick an arbitrary point, P, and this point has a distance from the current, which is R. Then we can write out the magnitude of the magnetic field like this. B equals K times I over R. B is a magnetic field, K is proportional constant, and I is current. R is a distance or radius from the current. Obviously, as current is increasing, magnetic field is also increasing. But if you move away from the current, then magnetic field gets weaker. So magnetic field B is proportional to 1 over R. The unit of magnetic field is Tesla. Tesla came from the famous engineer Nikola Tesla. K is a proportional constant. From accurate experiments, scientists measured the constant as 2 times 10 to the power of negative 7. We use this formula and we can find the magnetic field. This is the first example. When current is 10 amperes and the distance is 5 meters from the wire, then how can you find the magnetic field? Let's use this formula. So plug in numbers. K is 2 times 10 to the power of negative 7, and current is 10 amperes, and distance is 5 meters. So you use a calculator and simplify it, we'll get 4 times 10 to the power of negative 7 Tesla. Let's move to the second example. With the same setting, magnetic field is given 5 times 10 to the power of negative 7 Tesla, and distance is 4 centimeters, and we can find the current. The current is a current along the straight line. So one thing that we should be careful of is a unit. The distance is given in centimeters, so we need to convert it into meters. We need to divide it by 100, and we get 0.04 meters. Now, let's use the formula, magnetic field. Magnetic field is 5 times 10 to the power of negative 7, and K is 2 times 10 to the power of negative 7, and current is unknown, and distance is 0.04. In order to get I by itself, we divide both sides by 2 times 10 to the power of negative 7. And we can cancel them out. To get I by itself, we multiply both sides by 0.04. Then we can also cancel out the 10 to the power of negative 7 and use a calculator. You will get 0.1 ampere.